Hello, today we are going to see some new topics. First of that is ergonomics in design. Ergonomics consideration in design. So, first of all, we'll see what is ergonomics. Ergonomics is a study of relationship between man, machine, and working environment. It is the study of relationship between man, machine and working environment. While designing, we only consider a machine. Look at this diagram. If I am going to design a machine, I will only consider this machine. Okay, this is a machine. Take example of any machine. Suppose this is a universal testing machine or a drilling machine, any machine. While designing, I am only going to consider this machine. This is a machine design. But in ergonomics, we consider machine and a user. This is a user, and the relationship between this machine and user. We are going to consider this, and also we are going to consider a working environment. Why we should consider working environment? Because working environment affects the relationship between man and a machine. Now, a man machine working environment or relationship between man, machine and working environment. Why to study this working environment and relationship between man and machine? So objective of this study is make the machine fit for user. A machine should be designed in a such a way that it should fit the purpose of a user. A user should be able to use that machine properly without stressing the user. And the second objective is to decrease the physical and mental stress to the user. So how to reduce this physical and mental stress? This will be reduced if all the machine components which are in contact with a human being or a user are placed at proper location, and they are not awkwardly placed and easy to use. I will give you one example. In a house, all the electric boards or switches are placed at a certain height. You can see in your house itself, all the electric boards or switches are placed at a certain height. They are not far to below, uh, up to the floor level, or not very higher at higher level. Why they are placed at a height of 4 to 5 feet? Because a user can easily access that switch without any need of ladder or without any need to bend down. If a switch is at a height of 4 to 5 feet, then user can easily switch it on, switch it off very easily. And now consider if a switch is placed at very higher level, suppose a height of 10 feet or a 12 feet. So you cannot access that very easily. So each time you want to switch on or switch off any electrical appliances, you have to climb up the ladder, then switch on, switch off, and then come back on the floor. So this is a very simple case that I am telling you. Placement of a switch in a house is designed as per the human anatomy. Human anatomy means it is a study of structure of a human body. A average person, what should be the height of a switch, what should be the height of the control system, what should be the height of a display, that are we are going to study in ergonomics. So now consider this a closed loop system. Here it is a machine and a user. So in a machine there are two contact points with a user. First contact point is a display, machine display. Machine display is a first contact point. This is a machine display. So a user will read this display by seeing at it. Okay, so what is happening here? Information from display to user. So user is recepting or taking the reading from that display. This is a first contact point. This is a contact point where user taking the information from the display. This is first contact point. And second contact point is after reading or learning what is happening inside the machine, a user will take some corrective action. And how this corrective action will be taken? By using some control switches, some control mechanism. There may be some switches, a hand lever or a hand wheel or some brake. It depends, depending upon the machine, which machine you are uh, using. Take any example. In case of a universal testing machine, we conduct it. Suppose we are conducting a tensile test. Here is a workpiece and we are conducting a tensile test. So in display, the force, applied force will be displayed on the display. This may be a digital or analog or any other display. So a user will see how much force is applied to that specimen that is being tested. And if user feel that it is a less force, or there is need to increase the force, then user will increase this force by turning a knob on a control panel. In control panel there will be a knob, and by turning this knob user can easily change the value of force. So this is a corrective action. So basically in a machine, in any machine, I am talking about a general system, there are two contact points between machine and a user. These contact points are, first one is a display and second one is a control. Display gives the information to user and control takes the information or takes the corrective action from the user or a operator. So this is a closed loop system. Information is flowing, or a corrective action or information we can say is flowing through between the man and machine. So while designing a system, we have to consider these two contact points very stressful, very critically. This display should be at a proper height where a user can see and read this display very easily. So design of display is a very crucial from a ergonomics point of view. And second point of contact is this control. A control should be placed in such a height or such a position that user can, if a control is to be operated by hand, then it should be placed in a proper height. If it is to be operated by foot, then it should be placed properly so that user can operate it by a foot. Okay, so this is the loop system, man machine closed loop system. And again there is one more parameter or a factor in this, that is a working environment. Working environment also affects the relationship between man and machine. So what includes this working environment? This includes noise. Working environment includes noise. There should not be very high noise, or a proper light, temperature. These are all working environment factors. We are going to see this, but for your information I am going to tell you right now. So this is a closed loop system. Now what are the different topics needs to be studied in a ergonomic design? First one is, I have just mentioned a few to get you a better idea about this ergonomics. First one is design of a driver's seat. See, driver while driving a vehicle has to receive the information from different control panels, different displays over the vehicle, and has to correct the driving by using brake, accelerator, or shifting a gear. So these are all the controls, and he is receiving the information from a speedometer. Suppose for example a speedometer shows the speed, or a front glass shows the outside position of the vehicle, how the vehicle is moving. Okay, so this driver takes the information from this different displays and then takes the corrective action. By corrective action means he can turn the vehicle if required, he can press the brake, he can shift the gear. So these all are the controls. So correct positioning of these controls is a ergonomic study. Okay, design of driver seat, this is first example. Second one is layout of instrument dials and display panels. This is a one example of a dial. In this dial, we can take reading from 0 to 120. This may be of any parameters, say pressure, say velocity, or any other thing. But I've taken just a generalized example. We can take reading from 0 to 120. So layout of this dial, study of this layout is also a topic of ergonomic studies. Next one is design of a hand levers and hand wheels. This is a one example of hand lever, and this is a hand wheel. So designing of a hand lever and hand wheels is also a topic of ergonomic studies. See, a human body can apply a certain amount, average can apply a certain force to a lever. So, while designing a lever, this lever should be designed in such a way that it should be easily operated. It should not require too much force. Otherwise, what will happen? User will get tired very easily. If suppose take example of a shifting a gear in a vehicle, if gear shifting takes too much force, then what will happen? After using that gear shift lever for say 10 times, 20 times, then user will get tired. So we have to design such levers in such a manner that there should not be any stress to the user. And take example of wheel. The diameter of wheel should be such that it is easy to operate by using both hands. Okay, if diameter is very less, then it will be very difficult to operate by using two hands. Then this diameter of lever should be appropriate so that a user can easily hold that lever and operate it. So design of levers and hand wheels is also a topic of ergonomic study. Now, energy, as I have already told you, the force required to operate should be less. If force required is less, then less energy will be consumed by a user, and user will not get tired. Okay, in hand operation or in a foot operations. Okay. Next is final example is lightning, noise. There should not be any noise. Lighting should be proper, and climate condition means temperature, humidity, etc. should be maintained properly so that user will feel comfortable in that environment and work very effectively. So first we will see what parameters we should consider while designing a display. Okay, so while designing a display, these five things I have mentioned that are needs to be considered. First one is the scale on dial indicator should be divided in suitable numerical progression. See, this dial is divided in the steps of 10, 0, 10, 20, 30, 40, likewise. So if this is numerical progression is correct, then it is very easy to read. Now you can easily see that this is been in between 60 and 70, and it is very close to means in the middle of 60 and 70. So this reading is showing a 65. It is very easy. But suppose instead of 60 here is 30, and instead of 70 here is 80, and after 80 there is 120. So this progression is not uniform. Okay, so it is very difficult for a user to understand what is the exact reading. So first point you have to consider is that the progression should be like 0, 10, 20 in this fashion only. Next is the number of subdivisions between number divisions should be minimum. Yeah, this is also very important. Suppose this is a scale, this is a scale, and this is a main unit. Suppose this is a 1, or we can have, okay, 1, and this is a 10. So in between there should be a subdivision. Likewise, so this subdivisions should be minimum. Otherwise what will happen, it will take more time to read. Suppose a reading is in between here, suppose here is the pointer, so user will require more time to read this uh, number of subdivisions. But if there are only 4 or 5 subdivisions, then user can easily read it. uh, you have seen that in scale, uh, middle division, subdivision is always marked somewhat higher than the other subdivisions. This is suppose a 5, so it is marked somewhat higher. So this helps to reader to read a reading in very less time. And if time consumed in reading is less, then user can read number of reading without wasting much time. Okay, so number of divisions should be minimum. Next one, the size of letters or numbers on the indicator should be as follows. See, this is a numbering on a dial: 120, 110, 100, 90. This is a numbering on the dial. So what should be the size of this numbering? That is given by this empirical formula. We have seen what is empirical meaning. Okay, so this is a empirical formula. What should be the size or what should be the height of a number or a letter, and it should be always greater than or equal to the reading distance by 200. Suppose I am reading this dial from a distance of 2 meter. User is standing 2 meter away from this dial. Here user is standing, so this reading distance is 2 meter. So I can say 200 or 2000 millimeter divided by 200. So this will give 10 mm. So the height of a letter should be 10 mm for a distance of 2 meter. And likewise, if distance is more or less, then the size of letter will change. So while designing a dial, you have to consider that from where the user will read this. If it is reading from very close distance, then size will be different. If the user is reading from very far distance, 4 meter, 5 meter, then display letters or number size should be more. Now next one is vertical figures should be used for stationary dials. Okay, this is a stationary dial. Stationary dial means the pointer is rotating and this dial is stationary. Dial is not rotating, pointer is rotating. So in this case, all the letters and numbers should be vertically aligned. This 0 is vertically aligned, 10 is vertically aligned, everything is. So a person standing next to dial can read very easily. All the that letters should be written vertically aligned. If rotating dials are there, suppose a dial is rotating and pointer is fixed, in that case in that case in that case suppose this is a dial and it is rotating and pointer is fixed. In that case, you have to use radially oriented figures. Radially means this is 10, this is 20, this is 30. So this is radially oriented. So likewise, okay, if dial is rotating, then you have to use radially oriented figures or numbers. And final one is the pointer should have knife edge with a mirror in the dial to minimize the parallax error. Now parallax error means, suppose a user is not standing very perpendicular to the dial, Suppose this is a dial and this is a pointer, but there is always a different some gap between dial and the pointer. Let's take a side view. This is a dial and this is a center line and this is a pointer. This is a pointer and this is a display. And this is a pointer. So there is always some gap. There is always some gap between dial and pointer. So if a user is not standing very, suppose this is a user here. So if he is not standing perpendicular or seeing perpendicular to the plane of this display, then what will happen? If suppose he is seeing from this left side, then his pointer will look towards right side like this. Or if he is taking reading from right side, then this pointer will look towards the left side. So in incorrect reading will be taken by user. So to avoid this, to avoid this to avoid this, a knife edge pointer should be used with a mirror in the dial. So the dial surface should be mirrored one, so that the mirror image of the pointer will be visible to the user, so he can match the pointer and mirror image of that pointer and take a correct reading. Okay, for that pointer should be knife edge and a mirror in the dial is required. So this is all about the design of a display. So while designing you have to consider all these points. Now we will see uh, design of a controls, different controls. So what should be considered while designing a control? First one is control should be easily accessible and logically positioned. This is very common thing and you can very easily appreciate it, because if a control needs to be operated by hand, then it should be placed at a position where user can reach by his hands. If it is to be operated by foot, then that control should be very at lower height, so that user can reach that control by his foot. Okay, this is first point, easily accessible and logically positioned. If the controller needs to be operated by two hands, suppose a wheel is there, hand wheel is there, take example of a vehicle. That vehicle's hand wheel should be positioned, or we can say we can call it a steering wheel is positioned in such a location that both hands can easily reach that wheel and operate that wheel very easily. So first is related to the position, and second one is control operation should involve minimum motion and avoid awkward movements. Awkward movements is movement which is not natural to you. Suppose I have positioned a switch which should be operated by hand, but I have placed that switch very at lower height. Then to operate that switch I have to bend every time and then operate that switch. This is an awkward moment. Okay, and designers should always try to minimize the motion of a user. There should not be any motion if possible, but if not possible the motion should be minimum. All the controls should be closer to user, so that he can control all the knobs, levers, switches very easily. And next one is the shape of control component which comes in contact with hands should be conformity with anatomy of human hands. Okay, this is anatomy is a study. Anatomy is a branch of biology which studies the motion or a size, shape of the structure, human structure. What is the average length of a hand? What is the average force that a human can apply? What is the angle that can be turned through the human hands? Okay, you can see that in your hand your fingers can be turned forward but cannot be turned backwards. You cannot turn your fingers backward. This is a kind of restrained motion. Okay. We call it a knuckles. So in designing you should always consider the human body's anatomy, what is to be done very easily and what a human can't do easily. Okay, so while designing this should be considered. Then next one is proper color should be used. Okay, because this colors gives the psychological effects to the user. Suppose red color is used, then it will attract the attention of a user very easily. You might have seen that different switches are colored with red, which are very means controlling very risky operations. On off switches in a machine are colored with red color in a gray background, because red color attracts the attention very easily. It is very easy to call for attention. So proper coloring also helps the user to uh, focus on the task. Now we will see the working environment. As I have told you previously that lightning, temperature, noise, humidity and air circulation are the components or factor that affects the efficiency of a human being. Suppose I'm working in a room and the light in room is very low, the intensity of light is very low, then it will be very difficult for me to work for a long duration. Okay, and also this lighting depends upon the type of work I am doing. If I am doing very precise work, whereas very small components are needed to be handled, then the light should be, intensity of light should be more. There should be more brightness in the room. In the work table where I am working, their light should be more. If I am working on a somewhat bigger task, where very components are relatively in large in size, so there is no need of a very focused light or very bright light. Okay, we can design that system for a somewhat moderate lightning level. Okay, now consider the temperature. Temperature, again I want to tell you one point regarding the lightning. Lightning should be designed in a such a way that if I am working on this table, suppose this is a table I am working on and this is a room, then the light on the table should be somewhat higher. Intensity of light should be somewhat higher. Suppose this is a user standing here, so light should be higher on the table, work table where the user is working, and the rest surrounding light should be somewhat less, not very less but somewhat lesser than the light on the table. So this helps in focusing on the task. If light in surrounding is more, then user will get distracted towards the surrounding. So to avoid this, the proper lighting needs to be designed. This is just one example I am giving you. Now consider the temperature. Now human body generally uh, feel comfortable around 25 to 30 degrees Celsius. Okay, somewhat less than the body temperature. So a temperature should be uh, maintained, proper temperature should be maintained in a work environment, so that human can work for very long duration very effectively. Okay, also this is also depend upon the type of work. If I'm doing some heavy work, then the environment should be somewhat cold, not very cold but relatively cold. If I am doing some light work, because light work don't require too much energy, so I am not going to consume too much energy, then I can work in somewhat hot atmosphere. Okay, so this depends upon the type of work. Suppose I am working in a workshop on a machine where I have to physically pick up the heavy loads and put that loads on the machine and operate that machine by hand, then their temperature should be relatively low, so that operator can work there for a long duration. Suppose I am working in office where I am not doing any heavy task, I am only doing a task of writing, I know, working on a PC, then energy consumption is by a human being is low, so he can work in relatively hot. I'm not talking about very hot, but this is a relative hot and cool. Okay. Now next one is a noise. You can see that if while you are studying, if someone is making a noise, then you can't focus on your study. Same thing applies to all the environments, all the operators, all the workers. If I'm working on one machine and machine on other side is making a very high pitched noise, very high pitched noise, say the drilling noise. Okay, so such noise distracts the workers, distracts the operators, and also increase the stress, mental stress in the operator. Okay, sometimes this noise can be very dangerous also to the health of that operator. So noise level should be minimum, and best method to reduce the noise is to reduce the noise at the source itself, where the noise is producing. If I reduce that noise at that level only, then it is very easy to control, rather than controlling it in some other location. So where is the source, you have to find out that source and control that noise at that source only. It is very easy to control at the source. Otherwise, if it is not possible to control at the source, then you can use some um, soundproof walls, soundproof partitions, or you can use earplug, so that the noise will not distract the operator. So this is all about noise. Sometimes vibration also create very disturbing noise. Most of the time machines which are working on a very high speed or a very dynamic speeds, that creates the vibration, and this vibration is also annoying to the user. So reducing the vibration will also reduce the noise. And final is the humidity and air circulation. This is also one parameter, but this is very least important. These three parameters are more important. Human can work in a somewhat higher side of humidity or lower side of humidity, or if air circulation is less or more, then operator can work. But all these three parameters, lightning, temperature and noise, is very important. If these three are uh, controlled efficiently, then we can look after humidity and air circulation. Okay, this is all about the ergonomics in design. So what you have to control, what you have to consider while designing a uh, system. So for what we have seen, a display. First we have seen that there is a man machine closed loop system. There are 2 points of interaction. First point is display, where display gives information to user, and second point is control, where user gives information to the machine. These are two contact points. So while designing, you have to considering the design of these two contact points. Okay, so first we have seen the design of display. There are few points in that you have to consider or take note of, and then design of control, and then a working environment. Okay, so this is all about the ergonomics consideration in design.